Jai Hind everyone. Welcome back to the next lecture. We have already understood the force, then equilibriums, free body diagrams. These three topics we have already discussed in the last lecture. Now we will implement the free body diagram and all this and the analysis of the beam support reactions. So first of all, we will discuss what are the types of the supports we use in the beams, and then we will try to find out the support reactions. So now types of the support, there are the four types of the support. First is the roller support. Second is the knife edge support, hinge support or pin support, and fixed support. What support do? Support resist or support the load. What is beam? If I define, beam is a structural member which is used to support the lateral forces or transverse forces. So where this beam should transfer this force, definitely transfer to somewhere else. So where this force goes to, these are the parts or components known as supports. So various types of the support we use in engineering purpose. Roller support. So this roller support is like a cylinder. Suppose this is a beam. It is subjected to transverse force F. Roller support will allow to move this plank or beam in this horizontal direction. But this support will have certain base. It will prevent downward drop of this plank. It will permit this. Similarly, suppose this edge is knife edge, another knife edge, and we place some plank here, then this is also supporting if we apply some force here. This will not allow to move this plank downward, but this contact is a line contact. That's why this is called, or this is knife edge type. So this is called knife edge support. Edge support. Hinge. If this is a pin, this is pin, and I apply some force here, it will not permit to move it down, but it will allow to rotate. That is hinge support. Like in door, when you open or close the door, it does not leave the frame, door frame, but it will rotate along one edge of the frame in clockwise direction or anti-clockwise direction through the support. These supports are the hinge support, right, or pin support. Now the fixed support, if you put some element grouted in the wall, for example, then this support is fixed support. It will not allow to neither move or nor rotate, of that element. That is called the fixed support. Like this is a wall. If you put something here like this, then this support is fixed support. It cannot move in this direction, it cannot move in the downward direction, it cannot rotate. in this direction or this direction. This is called the fixed support, right? So normally, as we are discussing about the coplanar force system, so we come across these four types of the supports. Now we move to the next topic. What is next topic? As I have already mentioned, what type of motion one support permitted and what type of motion it prohibits. So, in which direction the support restrict the motion and the direction the reaction will be offered by the support. That is the reaction. So, if we consider this one, again, roller support. In roller support, if this is a beam, you have applied this force P, it will restrict the downward motion. Downward motion will be restricted by applying some upward force. So, at this point and this point, so you will write, say, if this is a point A, if this is a point A, this is point B, then this is VA and this is VP. These V stands for vertical. So, we have only vertical reactions in case of the roller support. If the force is not vertical, it is inclined at some angle. If it is inclined at some angle, if it is inclined like this at some angle alpha, then it will be, if having two effects or two components. One is the horizontal component, that is this, if this is P, this is P cos alpha. So, P cos alpha will have a tendency to move this beam or plank in the rightward direction, and this P sin alpha will move this beam downward. So, this roller support can only offer the resistance or the reaction against the vertical forces. It will not resist or offer any reaction along the horizontal direction. So, this is one point. I will tell you one more thing. In case of the beams, we must have a support roller or knife edge and other must be hinge support to make our or keep our problems in statically determinate range. If both are hinge supports or fixed supports, then it will come into the indeterminate beams. So, in our syllabus for this course, we are only dealing with the determinate beams, statically determinate beams. That's why I mentioned this line. Okay, one support should be roller or knife edge and other must be hinge, so that hinge can only resist this horizontal movement of the beam. Beam should not leave the supports, otherwise the purpose will be lost. Second is the reaction offered by the knife edge. If you this rollers replaced by knife edge, if this is knife edge, then also the same analysis you can perform. It will resist or offer the reaction against the vertical force. So, VA and VB will be induced. These are the reactions of this support, but against P cos alpha, it will not offer any resistance, and this plank or this beam will move in the rightward direction. So, it will not hold with the help of these two knife edge or two roller supports. So at least one support must be hinge support to keep it in position, right? Next is the reaction offered by hinge support. Next is hinge support. So in hinge support, I consider, suppose this is a beam, this is roller support. If it is mentioned like this, a triangle is placed over the rollers. This is always having rollers. It is known as roller support. And this is a triangle. And here a small circle. It is hinge support. This is hinge support. Now it is subjected to, again, inclined force P. This angle is alpha. So you will resolve this force is P sine alpha, and this is P cos alpha. So in roller support, it can resist only the vertical direction. So it will offer only one reaction at A, that is VA. Only one. This is, whether this is a knife edge support or roller support, it will offer only one reaction in the vertical direction. In the hinge support, neither it will allow to move. This is pinned here. It will not allow to move in the rightward direction cross. It cannot move in the downward direction because solid support is there, right? So it will offer two supports. One is VB and another will be HA or HB or HB. Right. HB. HB stands for the horizontal. I draw these reactions with the help of the dashed lines because the direction I will finalize after the analysis. If the answers of VB and HB will become positive, then these assumed directions will be perfect. Otherwise, whichever is negative, I will change the direction of that particular reaction in case of the hinge support. So, hinge support will offer how many reactions? Always two. Knife edge, it will offer on one. Roller support, it will offer one. This is in vertical direction, this is in vertical direction, this is in vertical direction and horizontal direction. Leftward, rightward, upward, downward. But it will not offer any resistance against the rotation, so it will not offer any moment reaction. In case of the fixed support, suppose this is a fixed beam, it is grouted in the wall. If you apply some force here, it will not move in this direction. So we have a reaction here. This is a beam. So we have a reaction in this direction. This is called H. If this is a HA, it cannot move in this direction or this direction because it is fixed. So I will show this is VA dash again the direction we will determine after the analysis. If the answer is positive, then the assumed direction is perfect. Otherwise, we will change the direction accordingly. Now, it cannot rotate either in this direction or in this direction. So, it will offer a moment reaction, MA. If applied moment is clockwise, then this will be anticlockwise. If applied net moment is anticlockwise, then the reaction will be clockwise. So, in this way, it will offer 3 reactions, fixed support. Right. I have mentioned on the very first slide, we have or we come across these 4 type of the supports. So, if we see under the topic of coplanar force system, we have only 3 equations of equilibrium, summation Fy is equals to 0, summation of moment about any point is equals to 0, 3. So, we can deal only 3 unknowns. So, only these 3 will be come into the category of statically determinate beams. You can have some prop type, you can put some support here also, one more reaction. Now, the unknown becomes 4, but equations are 3. So, problem becomes indeterminate. That is why I confine myself for these type of 4 reactions. Now, the types of the beams. First is the cantilever beam. What is cantilever beam? It is free at one end and fixed at one end. This is cantilever beam and subjected to the type of load you want to apply on it. You can apply the point load, you can apply the uniformly distributed load, you can apply the uniformly variable load, you can subject it this cantilever beam to the moment only. The combination of these 2 point load and the distributed loads, that is a cantilever beam. Now, the propped cantilever beam, what is propped cantilever beam? If this cantilever beam is having any support here, anywhere, apart from the fixed support, if this beam is having any support anywhere over its span, then this is called the propped cantilever beam. This is propped cantilever beam because this is fixed support. It will offer, if I draw the free body diagram of this cantilever beam propped, so it will offer, maybe this is M moment, this is V, and this is H. I assume the directions arbitrarily, and this is vertical B, this is A, and this is A. So, unknowns are 4, and to solve this in coplanar force system, only 3 equations are available for general procedure. So, we are not able to solve it, and it will be in the category of indeterminate beam. Now, come to the next, simply supported beam. Simply supported beam is a beam, which is supported by roller, hinge, knife edge and hinge at its ends. Right. This is a beam. This is having a hinge support. Here it is a roller support, we can show this like this. This is hinge support and this is roller support. Both are equal. Now the free body diagram, if it is subjected to some load W, vertical incline moment or UDL or UVL, then the reactions only. And only I want to discuss the reactions here. This is a beam, this is hinge, so this is point A, this is point B, so this is VA, this is HA, H hinge, moment reaction is not there, and this is VB. So only 3 reactions, it is solvable and determinate. So this is simply supported beam when supports are placed at the ends of the beam. And if this span length extends beyond the support, then the beam is called overhanging beam. Is called overhanging beam. So if this is a support, this is roller support, this is knife edge support or hinge support, hinge support, both cannot be same, roller and knife. Roller and knife should not be there together, right? One is hinge, this is roller, this is hinge, and this span is beyond or extends beyond this hinge support, and this is supported in load W. Now every beam is having its own weight. That's why it will be considered as overhanging beam. But if it is mentioned in the problem that the beam is weightless, then it will not be overhanging if no force is applied on it. Means in the extended portion, it is mandatory to having certain load, whether it is due to its own weight or if it is weightless, then the external load must be applied, then only it will be overhanging. If it is weightless, whatever length you want to extend, you can extend, it will not be in the category of the overhanging beam. Some force, some load should appear here due to any reason, due to its own weight or externally applied load, then it will be overhanging beam. So I think free body diagram, simple. This is roller support, vertical. This is point A, this is point B. So this is VA only vertical at B. Here a vertical VA and a horizontal HA and W here, or if some portion of this extended W downward weight, or if you apply some force, then you will mention that force on that side. This is overhanging beam. Now fixed beam. If a beam is fixed on both sides it is grouted, subjected to load W, then this is fixed beam. It will having 3 reaction on this side, 3 reaction on this side, will not be in statically determinate beam. Continuous beam, if a beam is having continuous support, number of supports more than 2, then it is called continuous beam. Sometimes 2 beams are joined with the help of the welding or any other mechanical method, that also comes into the continuous beam. flexed beams are there. If we place some steel beam, or we sandwich a steel beam between two wooden planks and use for certain purpose, then this will be in the category of flexed beam. So in this syllabus, we will uh, confine ourselves with within this cantilever beam, simply supported beam, overhanging beam. These three beams we will discuss in detail for this syllabus. Now, the types of load we apply on the beam, or come on the beam, because it is not necessarily it is one type of load, because use of or application, engineering application of beams, you can find in the bridges and buildings and heavy machines. So various types of load come subjected to the beams. So first and foremost is the concentrated load or point load. This is what? Suppose this is a simply supported beam. Reactions are acting at a certain point, concentrated at a point. So this is considered as concentrated load or point load. This is applied load W. If we are showing it at acting at a point, then it will be considered as concentrated load or point load. In fact, it is not possible to get point load in real time applications. It is not possible. But for theoretical purpose, or for sake of simplicity of our analysis, we assume this load is there. So suppose this is W, then Al Y is a value, discrete values we can get, and we want to get moment about it, then W multiplied by L, W multiplied by Y is the moment about these points. If it is not point load, then we have to perform some exercise to convert this other type of load into point load, and the analysis will become simple, because point does not have any dimension in the analysis. It makes our analysis simpler. Distributed load are those loads which are distributed over certain span of the beam, and here we will discuss a two specific type of distribution, that is uniformly distributed load, where the load intensity from one point to the other end of the span over which it is distributed remains constant, that is uniformly distributed load. And uniformly variable load, if its density or if its intensity varies linearly from one point to other point over the span it is distributed, is called uniformly variable load. And how we will represent on the beam, that we are going to learn here. Suppose this is a beam, it is subjected to, this is a hinge, here it is a roller support, and it is subjected to this. This height indicates the intensity of load. Unit is kilonewton per meter. So let it be 5 kilonewton per meter. And span length is this, over which it is applied. Another way to represent this uniformly distributed load it can be like this, and mention here it is 5 kilonewton per meter for what distance? This is distance, suppose 5 meter, suppose 5 meter, right? So for this purpose, as I have taken the moment in the last slide, I say to, I have removed that actually, right? So to take the moment about A or about B, this is not a point. This is not a point. This is distributed, uniformly distributed load. Similarly, suppose this is a beam, this is hinge support, this is roller support, and it is varying linearly. This is linear variation. Then this height, again, you may call it 10 kilonewton per meter or 20 kilonewton per meter or whatever. This is the intensity of load, and it varies linearly from 0 to, this is for example 6 meter over it. Again, the moment and the effect, we need to use some integration method to solve it. In the next, this is uniformly variable load. Now we should learn how we can convert these UDL into point loads. So you can observe the shape of this load diagram. This is what? This is nothing but, this is a triangle. Triangle, right angle triangle. This is perpendicular. And this shape or this shape, this is rectangle, or it may come a square. We need to remember these two things for the distributed or variable load. Now, in the next slide, we will try to learn, how we will get the equivalent point loads. So, for uniformly distributed load, I am taking the example of simply supported beam, but these type of the loads may be acted on a cantilever, fixed beam, prop beam, anywhere. So this is suppose 10 meter span from, this is A, this is B, and the intensity is 10 kilonewton per meter from C to D. Now the shape I have mentioned in the last slide of this UDL is a rectangle or a square, right? 10 kilonewton, 10 meter. So height is 10, length is 10, it will become square. That's why I made this separate second figure. So it may be rectangle or it may be square. So shape of this is span length, that is 10 meters. This is intensity, that is 10 kilonewton per meter. Now get this area. What is this? I say this is a load diagram. Now the area of this load diagram is equals to 10 multiplied by 10 is equals to 100 kilonewton This is 10 kilonewton per meter into 10 meter. Meter cancel out, remains 100 kilonewton. So this is the magnitude of equivalent point load. Now the second point where it will act. It will act through the centroid of the load diagram. So this is a square rectangle where the centroid lies. It always lies as the intersection point of the diagonals of the rectangle or a square. This is diagonal, so it will be 5 meters from here, 5 meters from here. So now I can draw the free body diagram of this beam. Right, it is clear. The magnitude of point load is 100 kilonewton and it will pass through 5 meters from point C rightward, 5 meters from point D leftward. So now this is the beam. This is the beam. Now the load and reactions. This is 100 kilonewton. This is hinge VA. This is HA. Here it is VB. So it is clear. Now it is a simpler problem you can solve. Summation Fy is equals to 0. What is summation Fy? VA plus VB is equals to 100 and summation Fx is equals to 0. So HA is equals to 0. There is no horizontal force. So we can calculate, and then moment. We will attempt the numerical problem separately. So this is the determination or the way you will get the equivalent point load for the given uniformly distributed load. We must know what is the shape. Now come to the uniformly variable load. Uniformly variable load. This is a beam. I repeat, I am using simply supported beam for the sake of simplicity for me. Then this is 10 kilonewton per meter, uniformly variable from C to D, A, B. At point A, this is a hinge. At point B, this is a roller, and the span, I consider this is 9 meter. Now the shape is triangle. Shape is triangle. This is 10 kilonewton per meter. This is 9 meter. So the area of the load diagram, this triangle is what? This is load diagram. So the area of the load diagram is equals to the magnitude of the equivalent point load. So P is equals to 90 kilonewton, 10 multiplied by 9 divided by 2. Area of triangle is half times base into height. So it will be 45 kilonewton. 45 kilonewton is the equivalent point load. Where it will work? It will work or it will pass through the centroid of the triangle. Where the centroid lies, it will be the intersection points of the 3 medians of this triangle. Since this is a right angle triangle, so this is 2/3 distance from the vertex. So if this is 9, then it will be at 6 from C rightward and 3 meter from D leftward. This is the centroid. So this will pass through this 45 kilonewton. So you can draw the free body diagram here. This is VA and this is HA. Here I will apply this 45 kilonewton vertical force. B is VB. Now this distance is what? If this is 6, this is 3, this is 3, for example, so 3 plus 6, it is 9 meter. 3 plus 3, it is 6 meter. Now we can apply. Now the problem will become simpler for the analysis, and we can apply the equations of static equilibrium. Summation fx is equals to 0, summation fy is equals to 0, and summation m is equals to 0. So here summation fy is equals to 0. So we will write this is VA plus VB is equals to 45 kilonewton. This is equation number 1. And now I will make a moment equation about point A. So I will write VB multiplied by 15, 9 plus 6 is 15, is equals to 45 multiplied by 9. So VB is available. What is 27 kilonewton? 45 into 9 divided by 15, and VA is equals to 30 kilonewton. Both are in positive, so upward. Now for HA, there is no horizontal force, so HA is equals to 0. I think this is clear. What is beam? What are the supports? What are the support reactions? And how many reactions offered by what type of the support? Then UDL and UVL, and how we can convert the uniformly distributed load or uniformly variable load into the corresponding equivalent point loads to make the analysis simpler. So for this lecture, I think this is enough. So we will start again with some good and engaging numerical examples for application of these concepts. Thank you. Thank you very much.